Yeah, that means they're absent without leave. You know what that means. The sensor this is fuel and emissions test 8. We're talking about oxygen sensors. The sensor that must be warmed and functioning before the engine management computer will go to closed loop is the O2S. That's not hard. Incidentally, I put you guys the rest of the worksheets that I'm going to give out for engine performance in that in your bin over there. There was a few of them, but they're quickies. They won't take you long to do if you knuckle down and get them done.
Holy moly!
Yeah, there's only 17 of them. But, okay, and that's the ones that just for the engine performance. You know, this is emissions. So the voltage output of a zirconia oxygen sensor when the exhaust stream is lean is. It's relatively low, close to 0 volts. Now the titania sensors, you know, like the Jeeps used to use, actually measured the temperature of the exhaust, and lean was high voltage on them. It was the opposite. Okay, so question number 3. Where is bank 1, sensor 1 located on a V-type engine?
Ooh, I know.
Where?
On the same bank as some of the ones located.
Yeah, that's the only way that works.
And it's before the cat.
And it's different on different makes. I'll talk about that before. Cylinder number 1 on a Ford is on the right bank when you're sitting in the seat of the truck, and it's on a Chevy, it's on the left bank. It's a little more aggravating whenever the engine's in there sideways, because sometimes cylinder number 1 will be on the front, sometimes it'll be on the
back. And the exhaust manifold too, so it goes A and B, right?
Mm-hmm. Well, it's not always in the exhaust manifold. You can't categorically say it's always in the exhaust manifold. Sometimes it's in the catalyst pipe. You know, the pipe leading to the catalyst. Exhaust.
Okay, yeah, I see what you're saying. I was thinking the whole tailpipe was the exhaust manifold.
No,
what would make the inside of your car smell like propane?
Usually you have a propane leak.
Does cars don't have propane in them?
Now, if it's propane you're smelling, you could probably, if you lit off a lighter or something, you could tell if it was propane.
Yeah, no, I'm not doing that while I'm in the car.
But I don't know if there's no propane anywhere in the car. Like if you left your propane bottle opened up and is rolling around under the seat, that would probably have something to do with it.
propane in my car.
You probably got something in there that smells like propane, but it's not propane.
It did it when I cranked up the car.
You also can't smell.
Well, your car doesn't run on propane, though.
I know, but it smells like.
It's making a smell
Yeah.
like that. I don't know what that would be, really. I'm not very good at diagnosing smells.
AC clean.
I've actually known of times when somebody would say, my car stinks so bad on the inside, and the mechanic went out there and found some 2-month-old lasagna under the seat that was all moldy and everything.
No, this is fuming.
Yeah.
Whenever I cranked up the car and started running.
Now there is such a thing as a hydrocarbon sniffer that we've got that you can see if it smells anything in there. But it would be hard for me to imagine that your car is creating propane out of thin air and pumping it into the car.
No, I know, but that's the only.
Yeah. Or what you're talking about, it smells like propane, but you really don't know if it's propane you're smelling. So.
Right.
Yeah, I'd reserve judgment on whether or not it was propane until we, found out for sure. Hey, Mr. Harrison, I got you a belt over there. I got you a belt that won't make noise over there. They sent one of those polycog belts that's all shiny and polished and makes noise, and I sent that right back, and I said, Garrett does not want to have to change that belt twice. Okay, so that's number 3 is actually D.
Oh, it is D.
Yeah, they say that, but I don't like that answer. I'm going to tell you the truth. In the exhaust manifold is lousy because it won't always be in the exhaust manifold.
And the exhaust manifold, that first little section that comes out of
It's usually it's either the header, the part that's the headers or the cast iron part, and that's.
I'm tracking.
And be prepared for this, because sometimes whenever you go to screw an oxygen sensor out of a manifold, it's 18 millimeter spark plug thread is what it is, and the threads will come with it, and it'll be all galled and everything. If you're having to screw an oxygen sensor out and put it back in, you need to put some anti-seize compound on the threads. If you don't, you're going to be probably sorry later. I have went to screw the spark plugs out and had the threads come with them. You have to have an 18 millimeter thread tap or thread chaser to fix that. Because basically this is a deal killer. You can't just... Have you ever seen anybody fix anything and they just sort of cram the part in the hole and hope it don't come out instead of doing it right? You know what I mean? That ain't a good way to go. You got to fix that. And And bless his heart, and I guess I probably should have given him a little more instruction, but did you hear that really, really noisy drilling that he was doing on that door panel the other day? You know why it was so noisy? He was drilling the hole with an easy out. And I said, good grief, he had the easy out in the drill. And I says, this is not for drilling a hole. He goes, well, it worked. I thought that was plumb funny. But I was wondering why it was taking him so long to drill those holes. He was just burning his way through that thing with an easy out. But anyway, he just laughed it off, whatever. Heated zirconia. I've never seen anybody do that before in my whole life, though. So you get the prize. So heated zirconia oxygen sensor will have how many wires?
I'd say it's either 3 or 4.
It's going to have 4 if it's heated, right?
What if it's not heated?
Yeah, if it's not heated, it can have 1. Like on some of your older GM cars, it depended on the exhaust heat to warm the sensor up to get it to where it was working, and that took a while. On that, some of the older Fords, some of the older Chryslers. Here's another thing, guys. Let's assume, for the sake of argument, that you've got one that's puffing rich, and you're wondering if the oxygen sensor might be the cause of that. Now, I've actually was working on a Chrysler product one time when I was at the Ford place, and at the time we didn't have any books on Chryslers. But I remembered something that one of the instructors at a school had mentioned earlier, long years ago, just commonsensical stuff. What if you could put some voltage into that oxygen sensor feed into the computer and trick it into thinking that it was running rich, and then the smoke goes away? You basically know categorically your oxygen sensor is, probably not doing its job, right? A 1-wire sensor I'm talking about. You got it good and hot, you can measure the voltage and all. Well, let's just see if there's something else besides the oxygen sensor causing it. So I just lick my finger, touch the battery terminal, and, touch the terminal of that harness going to the computer, and its smoke clears up.
That was enough voltage to do it?
Yeah, I was just feeding a little well, there's barely any voltage at all. All it needs is a whisper. And anything that it sees that's above a half a volt, it considers rich. And on that Chrysler, that took care of that. So it made it go away. Now, I didn't come up with that by myself. I got it from somebody. But here's the thing. When you're in school and you're listening to people talk on various different makes and models of cars and all that, occasionally you hear somebody say something that you need to burn in, because this is something I hadn't thought about that's really sharp. And it was one of the instructors or somebody that mentioned that. There's other things that you want to steer away from. And there was one guy in the school that said he was wondering if there was water in the gas tank on this particular truck. Of course, it had a metal gas tank. So he drilled a 1/8 hole in the bottom of the gas tank, let the gas go out of it, and then he put a pop rivet in the hole. And everybody in that class was going, where did this guy learn this? And where did he come up with this idea? I mean, that seems scary as all get out to me, to breach somebody's gas tank with a drill bit and then to put a pop rivet in there when you're done. I mean, yeah, maybe that's quick, but I don't want to make drilling holes in my gas tank, putting a pop rivet in there. And it better be a blind pop rivet too, or it's going to leak, Now, drilling the hole in the exhaust like we were talking about is one thing, but drilling a hole in a gas tank, we're talking volatile mix, man. Okay,
That's a metal one.
Huh?
Drilling with a metal one, that's got to heat it up, doesn't it?
Well, that's not, no, you're going to go through it so quick, of course, there is an outside chance there may be a spark, but there's no oxygen in the gas tank anyway, unless you took some in there with you. That's why a fuel pump, the gasoline that's being pumped by the fuel pump is flowing all around the brushes on the pump and everything. So it seems like there'd be some sparks, doesn't it? Seems like it'd go boom as soon as you turn on your key, doesn't it? And it doesn't do that because there's no oxygen in there. If there's no oxygen in there, there's no combustion, right? That's just basic stuff there. High O2 sensor voltage could be due to what?
Rich.
Both A and
Rich exhaust.
Okay, or rich exhaust. What do you got? Basically, rich is exhaust. That's number 5. That's only A. Could a defective spark plug wire cause high O2 sensor voltage? Or maybe a misfiring cylinder?
Well, if it's not
That'd be
burning up
hydrocarbons.
if it's not burning up the fuel, then that's taking it down. You're going to have more.
Yeah, if you're not burning the oxygen, you're not burning the fuel or the air. It's smelling oxygen, it's not smelling fuel. But, now here's the caveat to that. If it begins to read a lean condition, even though there's gas blowing past it that hasn't been burned, what's it going to do to the fuel trim? It's going to go positive with it. It can go positive far enough to where it can actually read rich. what I mean? So there's a little bit of a balance you gotta deal with there. But the conventional wisdom is, as soon as it starts misfiring, even if there's gas blowing past that oxygen sensor, the oxygen sensor don't know nothing about gas. We can smell gas, the oxygen sensor can't. You know what I mean? A low oxygen sensor voltage could be due to what?
D.
That's going to be what?
Lean exhaust?
What do you think, guys? That's going to be D. However, it could be B and C. Lean exhaust or a defective spark plug wire. That's what I was just talking about a second ago. All right, here's another thing. What if I happen to, I say, I think I'm going to check with my meter. I'm going to go into my oxygen sensor wire and I'm going to see if that thing's, what the voltage is that it's reading. Well, I go in there with my meter or my scope or whatever, and I see the doggone thing bouncing around 3 or 4 volts. And it's supposed to be, it's one of those that's supposed to go between 0 and 1. If I'm seeing 3 or 4 volts and I know for sure that it's not something like a wideband sensor or something like that, now what the sound mill's going to let the oxygen sensor voltage go that high? Here's the thing, you got a bad ground or you got a defective alternator. What you can do, sometimes if you unplug the alternator so that it quits putting out and the oxygen sensor voltage goes back to where it's supposed to, and you may have a bad alternator, but you could still have a bad body to block ground. Another thing that you got to think about is if the oxygen sensor ground, you know, this has got an oxygen sensor ground that goes from the engine and feeds the computer. If somebody has put it in a different place than it came, then you may have screwball readings because of that. On some of the Broncos 2s, little 2.8s, there was an orange wire that was going to the back of the cylinder head on the right side, and that was oxygen sensor ground. And let's see, it went to pin 49 on the engine controller, if I remember right. So what people would do, it was back there, actually it was on the bolt that holds the transmission dipstick tube bracket on those. And when I would see the, people would take the transmission out or whatever, when they put it back, that wire was waggling, and you'd have one that was puffing around running rich, and when you check the sensor voltage, because there was no ground, it would be bouncing around, 4, 5, 6 volts, whatever, crazy. So if I saw something like that, I would check oxygen sensor ground to begin with. On those 60-pin engine controllers, if you unplugged them, typically you're supposed to have grounds at 20, 40, 60, 16, and 49. So if you remember those pins, 16 is ignition ground, 20, 40, and 60 are your primary grounds, and then 49 will be your O2 ground. Let's see. Now, there were 3-wire oxygen sensors that were heated too, by the way, in regard to that other earlier question. I was thinking about that, but I didn't say anything before. An oxygen sensor is being tested with a digital multimeter using the min-max function. All right. Who knows what the min-max function is?
It shows the minimum and the maximum readings.
It captures the maximum and the minimum, and you can play them back. You're looking at where it is now. Maybe that's not helping me. I'm going to hit min and max. Oh my goodness! Look how high that went one time. Because it's basically going to capture whatever was the high and whatever was the low. All right, you're using the min-max function. The readings are a minimum 78 millivolts and maximum 932 millivolts. Average 442. Technician A says the engine's operating normally. Technician B says the oxygen sensor is skewed too rich. Who's right about that? That's A only. That's normal operation. And like I say, we're not talking wideband oxygen sensors. We're talking the regular ones.
Now, if the average over 500 would have been too rich.
Yeah, if it was average over 500, it would be slightly too rich. And I'm going to tell you something else that Chryslers will do. It will just drive you up the wall if you don't know what you're looking at. Whenever the oxygen sensor goes above a half a volt on the ones that are switching from 0 to 1, then basically as soon as it cracks above half a volt, the short fuel trim starts to go back in the opposite direction. As soon as it cracks below a half a volt, the short fuel trim goes back in the other direction. So if you've got your oxygen sensor and your fuel trim stacked on a graph in your scan tool, you're basically going to see a short fuel trim that looks like a sawtooth thing. And you're going to see the camel humps on the oxygen sensor, which is normal. So as soon as it goes lean, it's starting to correct rich. As soon as it goes rich, it's starting to correct lean. And it's moving all the time. And that's the way things work the best on these systems. But on some of those Chryslers, they feed a bias voltage down there. And that oxygen sensor can go bad. And it will actually stick at about 0.6 of a volt. And it can't go below 0.6 of a volt because it's just a screwed up sensor. And then what happens is it starts trying to retard the, take fuel trim away, and the engine begins to deteriorate in the way that it runs because it doesn't need fuel taken away, and it'll start to lose power, and then it'll realize, hey, I've got a problem, something's not working right, and it drops into open loop, and it jumps back up, and then it goes back into closed loop because that's desperately where it wants to be. And what the end result is, you'll feel the vehicle bucking and jumping, just something awful. It's just terrible how it does, like, what is all this? You go in here to look at your scan tool, if you see an oxygen sensor voltage hung just above 0.6 of a volt, or just above half a volt, it's going to think that's rich, and it's going to try to correct it unsuccessfully, and you're going to feel it bucking and jumping. Chryslers will do that worse than anybody else. You see what I'm saying? Now,
I smell something hot in the electrical.
did you burn something?
No.
I need to turn the voltage off going to that thing. That will prevent this from happening again. We turned off the juice box. Okay. All right, now then. I smell something hot in electrical too. But
How do you set it to min and max
Yeah.
for one of these things?
you've got to have, that one doesn't have a min and max setting. You got to have a meter that's got the min and max setting on it, and it'll actually say it on the dial, min max. Or you can, or have a button you can push it or something.
Do we have one here in the shop?
No. Well, yes and no. The Pico scope will do it, and that little scope on the little white table will do it. It's actually, when you put it in a voltmeter function, it has that capability. The $300 Tektronix beater I bought off the Mac Tools trucks many years ago has actually got it. It'll measure your fuel injector pulse width and all kinds of cool stuff. But okay, now everybody, front and center. All right. Let's see.
Great.
Oxygen sensor is being tested using a digital storage oscilloscope. A good oxygen sensor should display how many switches per second?
5 to 10?
Well, what do you think? I say 1 to 5, not 5 to 10. 5 to 10 is pretty doggone fast.
We were halfway fast, or
Yeah.
halfway right.
Halfway right.
Yeah. So if you do, I'm going to tell you this too. Oxygen sensors will sometimes flatline. And I mean, just flatline, and then they'll come back alive again. And what you'll wind up with, if it's in closed loop and it's trying to pay attention to the oxygen sensors and they flatline, it can cause black smoke and stuff, but it can also throw you a code saying that a lean exhaust condition was indicated. If for some reason you've also got one where the evaporator drain from the air conditioner is dripping on the oxygen sensor, it will destroy the oxygen sensor that way. We actually had to put some little diverter pipes on some of the F-150s because it was the drain was dripping on the oxygen sensor and was destroying them. Some of the oxygen sensors are a pain with a capital P to replace because they're in an aggravating hard place to get to, and they're also going to be kind of tight. One of the things that I did to get those, I got me a really good wrench, and there may be, there's all kinds of wrenches out there, but I got me a really good wrench, which was a 7/8, and I'm not good at drawing a wrench, so bear with me. I cut that wrench off about that long, and I've cut a notch in it on both sides, like that right there, and I would put that thing on the oxygen sensor, and I would find a way to get my big pry bar against that thing, and I'd break it loose like that, and then you can usually screw it out of your fingers, unless the threads are all shot. See what I'm saying? So that's really a little tool. I bought that. I've got one of those tools in here that I made, but I built one of those tools, and I used it I'll change a lot of oxygen sensors when I was working at Ford Place. And right before I left to come here, I was under a truck working on changing an oxygen sensor, and somebody came by there knowing that I was, going to be leaving, and they stole my wrench.
What?
Yeah, they just walked by and saw it under there and said, I think I'll have that. I mean, it disappeared from under the truck within a period of about 2 or 3 minutes, and I didn't see who walked by there, but somebody got it. Of course, the thing about it is, I got another 7/8 wrench. I'll just cut one off and make another one. It wasn't a big deal. I got one out there. I actually burned a hole in it with a torch too and tied a piece of wire to it so that I could, if I dropped it, I'd be able to retrieve it without it being going somewhere, if I was in a, but anyway, let's see, when testing an oxygen sensor with a digital storage oscilloscope, how quickly should the voltage change when either propane, like she's got in her car now, is added to the intake stream, or when a vacuum leak is created? How quick should it respond? Less than 100 milliseconds. It should respond very, very rapidly. Hey, I was thinking about what you were saying, the propane in your car, I'm interested in that, although I think it's just something that smells like propane. Somebody see if you can identify something, we'll have to do the Horatio Kane CSI thing. Today, we gotta find out what smells like propane, you know what I mean?
It smells as though, Rich,
Yeah.
something is up.
Yeah. Turn that air conditioner down a couple of degrees. Harrison, turn that air conditioner down a couple of degrees. PO 133 DTC is being discussed. Technician A says a defective heater circuit could be the cause. Technician B says a contaminated sensor could be the cause. Which technician is right about that? That's Charlie there. One of the most common things you're going to change oxygen sensors for nowadays is a heater. Now Daniel had a little experience on the Sam Hill was that Mazda, that little SUV that's like a Ford Escape except it's a Mazda Tribute. And Daniel, you remember what happened on there? What the situation was on that Tribute? It threw a heater code.
It wasn't seeing that O2 sensor, that was because of the wire.
The heater is what it wasn't seeing. There was a wire that was going from the PCM directly to the heater. It wasn't seeing. Now, if you've got a heater, let me hit you with this. This is important. When I say this is important, am I always telling the truth? I am, right? Everybody, I've never said this is important when it wasn't important.
Yeah.
Right. 12 volts coming in, right? I've got my little heater here in the sensor. This is going to be my sensor, just because. All right. This one here goes to the PCM, right? The PCM is the one that's going to decide how much current to deliver to that heater. The PCM can vary that current, and it's going to measure it too. The PCM, what should the PCM see here when it's not using the heater? What should it read right here when it's not using the heater?
0 volts.
12 volts.
Like that.
Why should it see 12 volts? It should see 12 volts because it's coming through the heater going up there. What Daniel had in his situation was it knew that it wasn't turning the heater on, but it was seeing 0 volts. See? If it knows there's voltage going into the other side of that, and it does this with all kinds of components. It does it with solenoids, it does it with speed sensors. It's going to know there's voltage going in the other side, and it's going to look for it to come out the side, this side.
Does it use another wire to turn the heater on and off?
No, this one here, it's just what you see is what you get. On your oxygen sensor, it'll be the 2 white wires, the 2 brown wires, or the 2 black wires. It's always the 2 wires that are the same color as the heater. It's supposed to have about 3 or 4 ohms of resistance. But the long and short of it was, this one didn't have it. So me and Daniel, what I like to do, and let me hit you with this while I'm still thinking about it. Everybody's had an old oxygen sensor in their hand that they just changed out, right? Okay, if you cut the, you will have. If you cut the, if you don't tap out first. But anyway, if you cut this connector off this oxygen sensor, and so you've got the connector that's come off the oxygen sensor, and you got your wires waggling, right? Okay, I'm going to get me a light bulb, and I'm going to hook it between the 2 wires that are the same color. That way, I've got a way that I can check that heater. So if I take this little tool I've made, and you can put a long lead on it if you want to, so you can pull it up here and hold it in your hand. It don't matter. Put that long lead on that thing. Maybe you could put a little box that's got a light in it or something. But you just need a little light bulb, like the little small, like a test light size bulb, and plug it into where the oxygen sensor goes, crank the car, that light should come on. If it doesn't come on, what does that mean? That means that you've got a problem either on the power or the ground side of this. Then you got to identify which is which. If you're smart, you'll run it through a little project box and you'll make a little breakout thing. You'll have 2 little banana plugs, one of them teed into the hot side and one of them teed to the ground side. And then you can take your test light or your logic probe and see what you've got missing. Daniel had, from between the PCM and the oxygen sensor, he had an open circuit in that wire. Now, it didn't go at about this far. I mean, probably 3 feet maybe 2 feet. And so what he did was he got another wire and he hooked it into the pin coming out of the PCM, and he went down to the oxygen sensor. He soldered and heat shrinked, which Daniel just loves to do that, which is okay, because loving to solder and heat shrink is a good thing in this business. And he put it inside and it looked like a factory job. The code went away. What triggered us was somebody had already replaced the oxygen sensor, and then when that didn't fix it, they gave up. See what I mean? But we actually went deeper and troubleshot it, and it wasn't complicated, it's just 2 wires, man. When I'm supposed to be grounded, the ground is switched in the PCM, the 12 volts is supposed to be there all the time.
So,
Pay attention to the fuses though, because you may have blown fuses that are feeding those oxygen sensors too.
you got 2 of the same wires coming out to a connector. The connector leads to the oxygen sensor. You're not gonna read 12 volts on both of those same wires at the connector.
Only if it's plugged in,
Only if it's plugged in.
because it's going to be going through the element in the sensor and coming back.
So it's coming from the 12 volts, and the PCM is reading the 12 volts.
That's right, it's reading it, and the PCM knows the 12 volts is supposed to be there when it's not grounded. I mean, that's the way it is with relays, that's the way it is with in fuel injectors, all of that stuff. And if the PCM sees an open circuit there, and it's thinking, when I don't have this energized, I'm supposed to see 12 volts. If I don't see 12 volts, I know that I've got some problem on that line. And it's going to tell you that in a code. You know, and that's what we did. All right, that's a little thing right there that I'm talking about. All right, let me see. Number 11 is the one we're on? No,
Yes,
10?
we got 10.
Oh, number 10 is basically going to be C. A contaminated sensor could be the cause too, you know, whatever. If it's got a bad heater, then it's not going to get hot, you know, and they would get a PO 133 on that. Of course, you'll get a code for a heater too, usually. Technician A says an oxygen sensor produces a voltage output signal based on the oxygen content in the exhaust stream. Technician B says if the exhaust has little oxygen, the voltage in the oxygen sensor will be close to 0 volts. We need clear thinkers here. Little oxygen means what kind of mixture? Rich. Lean means a lot of oxygen, you know. So a lot of oxygen goes low voltage.
And rich.
Rich is going high. So basically A is the only one that's right there. Technician A says an oxygen sensor can have 1, 2, 3, 4 or more wires depending on the style and design. Technician B says if the exhaust has little oxygen, the voltage of the oxygen sensor will be close to 1 volt. Blah. Let's forget about him right to start with. Number 12 is going to be
A.
wait a minute. Hey, let me read that again. I screwed up. Technician B says if the exhaust has little oxygen, the voltage of the oxygen sensor will be close to 1 volt and close to 0 if there's high oxygen content. He's backwards. Yet the answer key says both those guys are right. I know that's hogwash. A is the only one that's right. Put A on that one.
A.
Oxygen sensor cross counts can only be determined using what?
C.
No.
What is a dwell meter?
Ah, that's a good question. A dwell meter is basically going to measure what percentage of time a signal, something is closed. Like for instance, you're going to hook a dwell meter up if you've got a distributor with points. Of course, you can read dwell on just about anything that's opening and closing. But a dwell meter is going to read, like when your distributor's turning and your points are set, you know, to a certain gap to stay open a certain amount of time. The dwell meter is going to give you the amount of time that the points are closed. In other words, during the time whenever that little cam is turning and the points are closed, that number of degrees is actually going to be read there. You can also use a dwell meter to hook it up to your wire going to the torque converter on the transmission. And you'll basically, as it modulates the transmission, you see the dwell meter going up. It's a pretty cool tool. Most mechanics don't use them anymore, but they are usable for a lot of different things. On the old General Motors computer command control systems that had the metering valve in the carburetor, we would hook a dwell meter to those to see what percentage of time the dwell meter was, the metering valves were closed. Let me restart here. All right. So, but anyway, a dwell meter is basically that. It's basically supposed to tell you, and I think I've got one out there. I can probably demonstrate if I can find it anywhere. It's similar to, it's basically like measuring a duty cycle almost. You know what I'm saying? That's what it does there.
So that's it, dwell meter?
Scan tool is the right answer to that one.
Oh,
Scan tool will give you the cross counts. You might be able to figure it out, but the scan tool basically going to give you the official cross count number. Technician A says oxygen sensors can be tested using a test light or a dwell meter or a scan tool. Technician B says conditions can occur that cause the oxygen sensor to be fooled and give a false, lean, or rich signal to PCM. 14, that's B. Check out oxygen sensor with a dwell meter. That's HUI. And now you're not going to test an oxygen sensor with a test light either. Keep away from the little tiny little signals with your test light, because you're not gonna get any usable. If you can't get usable information with a particular, that's the same thing. If I'm using a doggone meter, a voltmeter, to measure the amount of current that's available to pull a load on a circuit, I'm not going to get any good information out of a meter, so I don't use a meter for that. However, on the other side of that, if I'm checking throttle position sensors and map sensors and these sensors on these cars, I'm not going to use a test light for that, because you're not going to get any useful data that way. You're going to do it while you're going to get your useful data. What's going to give you the most useful data, right? Okay, which one of these, and incidentally, what can fool an oxygen sensor into giving a false lean or a false rich signal? Give me an example of it. Anybody know? What's making my oxygen sensor, huh?
You told me this the other day, and I don't remember.
The catalyst, make them act stupid.
Not the one, no, because the one we're talking about is in front of the catalyst. But what if the signal that's coming from the oxygen sensor, wire is rubbing against the block somewhere? It's going to get shorted out. It's going to, and if it's coming and going, the things in open and closed loop fuel control is paying attention to that signal, and if that thing is bumping against ground every now and then and showing that voltage the oxygen sensor is creating is being shunted to ground before it ever makes it to the computer, then you're not going to have a accurate reporting of what your exhaust stream looks like. As far as the false ridge code, if it's shorted to voltage, it'll cause that. Which of these describes acceptable oxygen sensor cross counts?
8 to 10.
That's going to be B, 8 to 10 at 2,000 RPM. And the reason you go there, you might notice if you're looking at oxygen, and guys, there's some sheets in Engine Performance that talk about fuel trim and oxygen sensors and all this. You need to get used to those and piddle with them and work your way through there and take those worksheets seriously. And don't just watch somebody else do the worksheet and copy their numbers and turn them in, because you're not going to doodly nothing. That costs you. You may get past the thing, but you're not going to know how to do anything when you get out of here if you do that kind of stuff. But one way or another, if you rev the engine up a little bit and hold it up, your oxygen sensor is going to be switching quicker than it is if you're just letting it idle. If you're letting it idle, it's going to be a little bit lazier than it is whenever you're giving it more gas, because the changes are happening faster. A P0131 diagnostic troubleshooting being discussed. Technician A says an exhaust leak upstream of HO2S bank 1 could be the cause. Technician B says an extremely rich air fuel mixture could be the cause. That's a P0131. That's actually A. This is something else I didn't mention earlier that can cause it to move to false lean code. Let's say that your air management system, remember we were talking about the air injection reactor? During part of that process, it's pumping air upstream, isn't it? What if the air injection reactor system fouled up and it started pumping air upstream all the time? And it's going to be reading that oxygen, which actually was being pumped in there after the exhaust was, came out of the engine. And so it's going to sit in here saying, I'm seeing a lot of oxygen, and so it's dumping extra fuel in there to try to take care of that. Well, it ain't going to be able to take care of it because it's not making any changes. Now, if you've got a crack in the exhaust that's up there close to, like, between, you remember how I told you the exhaust system has got pulses? It's not a smooth, even though it feels like it. If you actually could measure it, it's got pulses. And so because it pulses, if you've got a crack that's configured the right way, it'll let some air pulse into that exhaust stream, and it'll go down there and confuse your oxygen sensor that way too. So basically what you're wanting to know is, what do I have letting air in, that's going to cause that? Possibly. This is what happens when you change the oxygen sensor thinking you're going to fix something, and it's just like it was. That's got you all disgusted now. But I'm going to tell you something else. Years ago when I was working, if I had any idea whatsoever that I couldn't trust my oxygen sensor, I'd change that thing in a New York minute. Because it's almost like a spark plug. Those things wear out. You know what I'm saying?
Pretty pricey too.
Yeah, some of them are more than others. Some of them are that bad,
Mine's $100.
Yeah.
The universals you splice off, that you have to splice the wires, those are pretty cheap.
Yeah, I don't like those, but if you're in a pinch, you can get by with one, I mean, I don't like anything. If you say universal, I don't like that. I don't like the word universal. The little vacuum tees that look like a Christmas tree because they step. I hate those darn things. I don't like universal health care, any of this stuff. I don't like any of that stuff. Excuse me, that was political. I shouldn't have said that. Okay.
You don't want to rant about healthcare on Facebook.
Yeah. Yeah, I'm basically just taking it as a guy to task about it. Let me see. PO 132 is being discussed. Technician A says the defective oxygen sensor could be the cause. Technician B says heated oxygen sensor signal wire could be shorted to ground. Could be false.
Both.
No, that's A. It's actually just A. Okay, so if you put both, slap yourself. Okay, when the concentration of oxygen on the exhaust side of the thimble is low, a voltage is generated between the electrodes. A voltage of what is generated between the electrodes?
A.
That's actually going to be B. Slap yourself. Okay, 0.6 of 1 volt. A large amount of oxygen in the exhaust system, it causes the oxygen sensor to produce which of these?
Oh,
A large amount of oxygen in the exhaust system causes the oxygen sensor to produce which of these?
A.
a low reading.
Low voltage. Slap yourself. Okay.
Yeah.
All right.
That's who did it.
Yeah, we've been talking about this the whole time. You don't know that. Okay. Hey, this is cool. We got pictures on this next page here. What does the post or downstream oxygen sensor measure? Daniel, you know that, don't you?
B.
I know that one.
What?
B for D.
B.
What is it? What is it? What do y'all?
How well the cat is doing its job.
To store oxygen. It's basically, it's measuring how well the cat store, how the amount of oxygen behind the catalytic converter.
That's always right.
And remember I told you, it's supposed to be, well, here we go. Number 21, with the vehicle in closed loop, meaning it's paying attention to the oxygen sensors, the following post converter, post meaning after, in other words, just downstream, HO2S scope pattern activity is seen here. What does this indicate? Now this is the top graph. What does that mean if you're seeing after the cat, you're seeing that voltage just lazily drifting?
So that's good.
Yeah, that's pretty much, what do you think? That would be C, wouldn't it?
Yeah.
Yep, that's right. With a vehicle in closed loop, the following post-converter HO2S scope pattern activity is seen. What does this mean?
Bad converter.
Yeah, if it's actually following the front sensor, then it's bad news. A wideband oxygen sensor was first used on a Honda in what model year?
That would be 1943.
They actually did that in 1992.
That was my next guess.
And that's
There's been
20.
a lot of really extreme changes in the 90s.
Yeah, they did. I mean, everybody was trying to get everything. Well, I will tell you what went on there. The emission standards started to really tighten up in the 90s, and not just on gas burners, but on diesel as well.
But I mean, that's when OBD2 became required and all that.
Yeah, that was during that period of time. It went there, and and it started. When was what was the first? Anybody know this? Since we're in emissions, and this is a little trivia question. What was the first emission control component ever put on any car, and when did it happen?
The muffler.
The muffler is a sound control item. It has nothing to do with emission control. Some people can read a gum wrapper and unlock the mysteries of the universe, and some people can read Tolstoy's War and Peace and think they read a little adventure story. I was quoting Lex Luthor in that Superman movie. Okay, so what you got was the PCV valve that was put on the Corvair in 1962.
Chevy Corvair.
Before they had a PCV valve, they just had a draft tube that let the crankcase vapors out into the atmosphere. And you could go to some of those big cities and they had a cloud of smog hanging over there. You couldn't even breathe. Burn your eyes. It was terrible. The traffic cops, before they had traffic signals in a lot of cities, and you'd have the guys out here doing this, you know. Oh, how would you like a job out there doing that all day, you know? All right. Okay.
Get creative.
A wideband oxygen sensor is capable of detecting the air-fuel mixture from what rich to what lean. Now we're talking air-fuel mixtures by weight, not by volume, okay? 24. Which one is it? Anybody know? Let's look at 10.1 to 23.1.
Okay.
You see, the reason you're doing it, that's why they call it a wideband, you're basically wanting to be able to look at a mixture that's farther apart. And under certain conditions, you want that thing to be able to modify it between those ranges, which gives you a lot more control. A wideband oxygen sensor and a conventional zirconia oxygen sensor can be made with what designs?
Cup and thimble.
Finger thimble.
This probably be B. Cup and planar. A wideband oxygen sensor can be made using what design?
Thimble.
Cup and
That's
planar.
26. That's C. Dual cell and single cell. A wideband oxygen sensor heater can draw how much current amps?
B.
That's going to be dog, 8 to 10. D. Delta. Yeah,
That's a lot of amps.
it's a lot of
Yeah,
amps,
it
it
is.
is. Well, why is that? A wideband oxygen sensor's got to get to 1400 degrees before it really starts to work right. The older ones, the zirconians, 600 degrees.
And it's because of that heater that they gotta,
The heater, they put the heater in there to bring it online quicker. You know, the quicker they can get that thing paying attention to the oxygen sensor, the better your emissions are going to be. It's just like back whenever they still putting carburetors on vehicles, and they had a lot of them on there when I, good grief. Even when I went to work at the Ford place, we were fixing carburetors all the time. You tap the gas, the choke shuts. The choke was supposed to be completely wide open within 90 seconds. Seems fast, doesn't it? How many of you ever drive a pickup or something you had to pull the choke on? You forget to close the choke. You forget to open the choke. You're going to thin the oil. You're going to foul your plugs. There's all kinds of stuff going on. Let's see. Wideband oxygen sensor needs to be heated to what operating temperature?
2,000 degrees.
1400. Yeah, I just said that, Lundy. All right. 1400 degrees. Yes, I joked about it. Okay, we've only got 68 more questions left. Okay. No, not really. The two internal chambers of a dual cell wideband oxygen sensor include, what do they include, y'all? That's A, air, reference, and diffusion. When the exhaust is rich, the PCM applies a blank current into the pump cell. What do you think about that? That's C, believe it or not, negative current. When the exhaust is lean, the PCM applies a blank current into the pump cell. That's going to be A. Number 32. A dual cell wideband oxygen sensor can be tested using a
All of the
what?
above.
All of the above. Voltmeter, scan tool, scope. In some hybrid electric vehicles, the wideband oxygen sensor can cause the PCM to enter closed loop. When?
A.
That's B, actually. You got that? As soon as the engine starts. I mean, that is like right away.
What is I?
Internal combustion engine.
I knew that.
Well, actually, they only started using that acronym when they did hybrids.
Because everything prior to that was all combustion.
Yeah, that's right, too. 34. A conventional oxygen sensor has a reading of 900 millivolts on a multimeter. This indicates what?
See?
Lean.
Rich, Betty boy. Higher voltage is rich. Unless it's a Jeep Cherokee between 87 and 90, and then 5 volts is lean and 0 volts is rich. Those are backwards. You know that pink voltage trace I got on that one computer out there for the background? That is, if you look at the voltage, that's a 90 model Jeep Cherokee that's got that old Bendix fuel injection system on it. And it was, as 5 volts is lean and 0 volts is rich. It's backwards as all get out, and everybody else is, but it's measuring the temperature of the exhaust is what it's doing. All right, let me see here. What number are we on? I forgot.
35.
35. A conventional oxygen sensor heater keeps the sensor at about 600 degrees. 36. One advantage of a planar type oxygen sensor is faster light off time. When the air-fuel ratio is expressed as lambda, a lambda number of less than 1. Now pay attention, guys. Your scan tools, a lot of them are going to be reading lambda
What is a
instead
lambda?
of, the other stuff. So what do you think? 37, that's going to be C, basically. Less than 1 is a rich exhaust on one that's reading lambda.
Okay, well, what's a lambda?
Technician A says a wideband oxygen sensor, also called a lean air fuel, can detect air fuel ratios from as rich as 10.1 to as lean as 23.1. Technician B says the oxygen sensor signal determines fuel trim that is used to tailor air fuel mixtures from the catalytic converter for the catalytic, not from the catalytic converter. That's C, both of them. Okay, the heater circuit in a wideband sensor heats the sensor to about what?
12 to 1400.
12 to 1400 on a poorly running engine. The wideband sensor can be quickly checked by doing what? Let's just jerk the sensor connector off and see what happens. I mean, don't break it, but disconnect it. A conventional oxygen sensor uses about how many amps?
See,
8 to 10?
D.
D.
Now let me ask you this. What did I tell you the resistance was?
3 to 400.
Well, like 4 to 6 usually. I got 12 volts and I've got 6 ohms. How many amps is that? I've got 12 volts, I've got 6 ohms. How many amps?
2.
Alright, now what's the best answer based on that?
B.
That's B, 0.8 to 2 amps. Now it's going to change a little bit when it heats up. Just like glow plugs on a diesel, glow plugs on like on these Power Strokes and all, I would get my inductive amp and I would go around the one that feeds all of the glow plugs, and when I turned it on, I ought to see 200 amps when the glow plug first light off, and then it'll drop back to 125. That's because a cold glow plug of the kind I'm talking about will pull 25 amps, and when it gets to operating temperature, it's pulling 15. Well, what happens if I hook around that thing and I turn on the key and I'm only seeing 175 amps? I know I've got one bad glow plug. I don't know which one it is, but I know I've got one bad one. Alright, 42. Most service information specifies that what be used when testing a wideband oxygen sensor?
Probably a factory.
Factory scan tool. They like for you to have a factory scan tool. Now then, you see how fast this particular little worksheet can be done here?